Good morning, ladies and gentlemen. My name is Jared Timmer for Trelleborg Industrial AVS, and I'm going to talk a little bit about solving noise and vibration issues on board of offshore vessels. In offshore vessels, people tend to like to bolt everything down with big, strong bolts. That's not often the right solution, because vibrations that are created by all sorts of installations on vessels create noise and vibrations to people, which will give all sorts of problems with people, in the end becoming a safety risk and loss of concentration. Beside that, the machines and the structures will suffer from vibration levels, which will give premature fatigue life, downtime and cost. A lot of installations on board of offshore vessels create vibration. There are such as diesel generator sets, compressor installations and pump installations and many other rotating equipment. The forces that these have can cause high vibrations on the equipment itself and on the vessel, resulting in costly and premature machine failures. Optimal vibration isolation can solve these problems. 90% of the transmitted force or more can be isolated. It all starts with a good analysis of the system. For that, one needs a very good software program that can take all the parameters in, calculate the 6 degrees of freedom, calculate the shock inputs if there are any, the deflections, and you can put in torque, engine excitations and moments. The principle is pretty simple. Every object has its own natural frequency. All we do is changing the natural frequencies by using anti-vibration mountings. One can imagine when you use something soft under a body that the natural frequencies are far lower. The point is to have a natural frequency that is a factor 2 or more lower than a disturbing frequency that the machine creates. A disturbing frequency depends on the type of machine that it is. The loads on the anti-vibration mountings are very important. They need to be relatively the same so that all the mountings get the same deflections. If that is not possible because of the center of gravity that is totally out of way, we can use different stiffnesses of mountings to still create the same natural frequencies, the same deflections. The dimensions between the mountings should not exceed 1.5 meter not to create bending of the structure. The stiffness of the structure obviously is the responsibility of the customer, but still we need of course to give them advice in that. There are certain applications where 3-point suspensions are required. In that case, the constructions need to be very stiff and we can create 3-point suspensions. It all starts with getting the right center of gravity and the loads of the installation before we start the calculations. Besides that, moments of inertia can be needed and any other information of the installation. The resilient mount system obviously gives the opportunity to the installation to move under seaway conditions, pitching and roll. So a lot of mountings have internal buffers to allow to create just as little as possible movement, or additional buffer systems may be needed. All other connections on the installation need to be very flexible to make it possible to move. It is clear that the acoustic performance of a system is as good as its weakest path. That means that if you have, for instance, very stiff cables from a generator that are pulled down through the deck, you have a vibration leakage and 90% of your solution will be destroyed. So you need to solve that sort of issues as well. Beside that, the stiffness of the foundation is critical for the result. The stiffness of a foundation should roughly be 20 times the stiffness of the mounting system. If that's not the case, you need to go to far softer mounting systems to still get a good result. There are a lot of factors that affect the mount selection, and it starts with the type of machine that it is, the number of cylinders, the cylinder configuration, the running speed, the possible torque, the unbalanced forces that it has, and all that sort of parameters that we need to have before we can start a calculation. And also the environment plays a role. The temperature in which the machine needs to operate, because rubber, for instance, can live up till roughly 90 degrees C constant for special compounds. If the temperature is much higher, we may need to go to the different solutions. Rubber is alive, we say. It basically, it is made, the electronic anti-vibration mountings are made of rubber compounds that are made of natural rubber, and the polymers that it's built up of are connected with little bridges. These bridges break in time, and then you get the effect that the mounting goes down, the stiffness increases, and you get a different system. After 10 to 15 years, you may have to replace your mountings. It depends a lot, this effect called creep depends a lot on temperature. The higher the temperature, the more creep you will have. Still, low creep compounds are created to make this effect as little as possible. After making the calculations and actually putting the mounts on a system, one can do FFT analysis, measure the vibrations to see if the calculated effect is really there. This can be done as troubleshooting, or it can be done to verify the effects of your calculation. Vibrations are not only in your vessel, but also on the machine itself. And when you put the machine on anti-vibration mountings, it will still have some vibration on it. If it's a very difficult machine with lots of unbalanced forces, those vibrations may be too high and they need to be verified. There are international standards for that based on the velocity on the equipment, like VDI 2056 and ISO 10816. For the offshore industry, reliability and safety are key, also for the anti-vibration mountings. In case of a problem, there needs to be an agreed and rapid recovery plan, because downtime is very costly. We supply with the products a complete manual supplier data book with all the relevant information of the products and this specific project in it, so that the customer knows at all time what he has and what he needs to do with it. The vibration analysis at the start and the FFT analysis at the end will prove that the system works properly, and we can create solutions and products for every type of application and technical challenge. As we stated before, natural rubber does not like oil, and because of that, a lot of our products are covered with a special paint that is oil resistant. It needs to be a very flexible paint because the rubber obviously moves and the paint should not come off. Beside that, we have developed a very special coating called Dragon Coat, which can retard the moment of toxic fumes when there is a fire from the mountings. The delay is an extra 3 minutes, and 3 minutes can be quite a lot to save lives in case of such a hazard. Thank you very much for your attention, and are there any questions?